Very good morning, all my dear students. Vanakkam. Welcome back again to your Unacademy NEET English channel. I hope that everyone is doing great. Have a good time. First of all, let me know that everyone can see this board. Everyone can hear me, can see me, my dear students. Just to let me know. Wow, Rahul Kumar, welcome, Priyanka, hello. So first of all, I would like to say sorry, extremely sorry. There was technical glitch, major problem, but yes, the team has sorted out, and I'm here with the fantabulous name reaction, which holds a hell lot of weightage, my dear friends. This is the best, you can say, the backbone. One was the GOC, and second is being the name reactions. Trisha is there, Nandini Devi is there, Loyal Man is there. Wow, warm welcome, all my dear friends. Really, this is very important thing. Now, let me tell you, my dear friends, the name reactions, aldol condensation, Claisen, Cannizzaro, there are at least 50 name reactions which are in your syllabus. Some are very important, some are less important. I will give stars. My dear students, whenever I'm going to teach any name reaction, for example, aldol condensation, I will give 15 stars. If I'm giving 15 stars to any name reaction, like I will write 15 stars. I'm writing 15 star to any name reaction. That means that name reaction is very important. Each and everything you have to know for that. Means related to that name reaction, whatever the things are involved, you should have to know. Suppose you are sleeping and someone is saying, hey Ramu, what is aldol condensation? So immediately you start, aldol condensation is like this. 15 star means this is the maximum star. All these reactions are having 15 star. If I am giving 5 star to any name reaction, that means you can leave it. 1 star, you can ignore it. Means if I'm giving 10 or more stars to that particular reaction, that means that reaction holds a hell lot of weightage. Why I'm giving stars? It's so that you can understand these reactions you can never ignore. Are you getting my point? Everyone. J Topper is there. Fantastic. Dr. Ritika is there. Jagantha is there, Prabhu is there, everyone. Wow, Shakti Ganesh is there, Gautam is there, everyone is there. Welcome, my dear students, welcome. Now, let me tell you, all these reactions, they are 15 star, 15 star, 15 star. Why only these reactions I have written? Because today I will start with these reactions. We are not going to do all the name reactions in one shot. Why? These reactions require time for revision, for doing number of questions. I can complete all the reactions. Suppose if I'm going to take marathon for 10 hours and I'm going to complete all these name reactions, 50 name reactions, all total 50 name reactions if I'm going to complete. Suppose if I'm going to complete all 50 name reactions in one marathon, so my dear students, that will be okay, but you won't be able to keep these name reactions in your brain. It's completing is nothing, it's not the solution. The main thing required is just you have to keep each and everything in your brain. So 5 name reactions we will cover in one syllabus, but we will do those name reactions in such a way that whenever any type of question is going to be asked, you can complete all, you can give correct answers to all the questions. My dear students, if I talk about this aldol condensation, if you are able to understand this aldol condensation, that means 20 name reactions you can do by yourself. The mechanism which I am going to tell you about aldol condensation, that means 20 name reactions mechanism will be based on that name reaction only. So this is the base. So are you able to understand? J Topper, thank you. Gautam, thank you. Everything guys, thank you. So is everyone ready, kids? And let me tell you one more thing. This ozonolysis, this is like whenever you're going to eat something in the restaurant and you are having water for this. This ozonolysis is just like water. This is just like water. Trisha, welcome, welcome. This is like water. This ozonolysis is must. Without this ozonolysis, you can't do anything. Very, very important. So 15 star to this also. So my dear students, everyone ready? Let's start from aldol formation and aldol condensation, right kids? So are you ready? Show me the thumbs up. That is everyone ready, my dear students? What I want to see is everyone ready? If yes, with the Josh, with the energy, and you have to make one promise that each and everything you have to keep it in your brain right now. That promise I want, and everyone hit the like button, smash the like button. You have to mark your attendance. If your attendance is marked, that means you are disciplined. Your regularity is marked in the form of attendance, in the form of like. Smash the like buttons, kids, everyone. Very good. So let's start with aldol formation and aldol condensation. So see to it. One thing is aldol formation and another thing is aldol condensation. How they are differ, let me tell you, my dear friends. Aldol formation aldol condensation. So kids, if I talk about aldol formation, aldol condensation, we can also use the word ketol, but ketones are less reactive. So ketol is this word, ketol condensation is less important. This is less important because ketones are less reactive. Now, my dear students, whenever this aldol condensation or ketol condensation or aldol formation term is there, we have to understand acidic alpha hydrogen atoms. So remember that I'm going to start with these reactions. This reaction holds a hell lot of weightage, 15 star name reaction. Now, to show aldol formation, at least one acidic alpha hydrogen is required. What is the necessary condition? Just try to keep it in your brain. To form aldol formation, what is required, my dear friends? At least one acidic alpha hydrogen atom. For formation 1 and for condensation 1, 1 plus 1 becomes 2. So for any compound, to show aldol condensation from the starting, how many acidic alpha hydrogen atoms are required? Kids, do let me know. Just from the starting to show aldol condensation, let me know, kids. Aldol condensation from the starting, at least 2 acidic alpha hydrogen atoms along with dilute alkali. Now, kids, there are two things. two acidic alpha hydrogen atom and dilute alkali, and these two things really holds a hell lot of weightage, my dear friends. Let me tell you, without this we cannot understand anything. So knowledge of these two things must. One is acidic alpha hydrogen atom means what, and dilute alkali means what. So everyone ready, kids? Yes sir. Now see to it, kids. Acidic alpha hydrogen atoms means what? How to find out acidic alpha hydrogen atom? In aldehyde or ketones? Aldehyde or ketones or both? Now see to it. If I write any organic compound like this, CH3, CH double bond O, just understand this is known as carbonyl group, my dear friends. This is known as carbonyl group. And any atom directly attached to carbonyl group is known as alpha carbon. This is alpha carbon, and these hydrogens are alpha hydrogen atoms. So this compound is having how many alpha hydrogen atoms? Do let me know, my dear student. Do let me know, everyone. You have to give the response. Quick. This compound is having how many alpha hydrogen atoms? I need answer, otherwise you won't be able to give the answers of the questions. This is having 3 acidic alpha hydrogen atoms. 3 acidic alpha hydrogen atoms. Are you getting my point? Now, if I write down this compound, do let me know. If I write down this propanol, CH3, CH2, CH double bond O. This propanol is having how many acidic alpha hydrogen atoms? Do let me know. Good morning, Shiva Kumar. Good morning. Welcome. It's do let me know how many alpha hydrogen atoms this compound is having. Just see, this is carbonyl group and directly attached this carbon, and this is having 2 acidic alpha hydrogen atoms. Now, what do you mean by acidic, kids? Let me explain. Alpha hydrogen is different thing and acidic is different thing. Let me tell you the difference in between these two. Just see to it, kids. If I say I'm having this compound CH3, CH2, CH double bond O, and another compound I'm having like this CH2 double bond CH, CH double bond O. Now, the first compound will show aldol condensation, whereas second compound will not show aldol condensation. What I'm telling you, this second will not show aldol condensation. The first will show aldol condensation. Why? See, this is your carbonyl group. This is alpha carbon. This is alpha carbon. This is carbonyl group. This is alpha carbon. Both are having alpha carbon. It is having 2 alpha hydrogen atoms. 2 alpha hydrogen atoms. It is having 1 alpha hydrogen atom. Now, my dear student, this carbon is the hybridization of this carbon is sp2, and this carbon's hybridization is sp3. So remember that, my dear students. Remember one thing: the alpha carbon must be sp3 hybridized, then only its hydrogen is acidic. These 2 hydrogens are being acidic. These are acidic, but this is not acidic. This is not acidic. Remember that. This is vinylic hydrogen. Vinylic hydrogens are never acidic. What is vinylic hydrogen, my dear friends? Vinylic hydrogen, which is attached to olefinic carbon, the sp2 hybridized carbon atom. Everyone getting my point? So this must be sp3 hybridized. Then only the compound is going to show aldol condensation, otherwise not, my dear friends. Got it? Very good. Now see, it's how the aldol condensation is going to take place. But before that, you have to answer one question, my dear friends. You have to answer one question. I'm going to write down the compound's name, and you have to tell me how many acidic alpha hydrogen atoms. Compound find out total number of acidic alpha hydrogen atoms. Then only we will start the game. Now, suppose if I write CH3, C double bond O, CH3. This is known as acetone. Acetone. Now, find out how many acidic alpha hydrogen atoms acetone is having. Yes. Do let me know. Fast, fast, fast. Hey kids, if you are taking that much of time, we won't be able to do anything. Fast, quick. 6. Very good. These are the 6 acidic alpha hydrogen atoms. This is alpha carbon. That side also alpha carbon. So 3 plus 3, that is coming out 6. Fantastic, my dear friends. Fantastic. Now, let me give you another compound. If I give you this compound, C6H5, CH double bond O. This is known as benzaldehyde. 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 Just to let me know, this compound is having how many acidic alpha hydrogen atoms? Fast. Quick, quick, quick. Yes, it's fast. I want the answer. If you want to get the rank, just to let me know. Beta Janani answer is, Gotham answer is absolutely correct. 0. 0. It is not having any acidic alpha hydrogen atom. That's really fantastic. Now, if I give you compound like this, CH3, C double bond OH. Now, this compound is having how many acidic alpha hydrogen atoms? Yes, everyone, just to let me know. I'm waiting for your answer, my dear friends. Yes. Very good, my dear friends. Very good. Because this is carbonyl group and that side no alpha carbon. This is alpha carbon and this is not having. So it is having 0 alpha hydrogen atoms. That is really fantastic, my dear friends. Now you are in the right path. Now, if I say we are having compound like this, CH3, C double bond O, CH3. This is the last compound, my dear friends. Do let me know. This compound is having how many acidic alpha hydrogen atoms? I want to see. And this compound is having, this is formaldehyde. This compound is having how many acidic alpha hydrogen atoms? The first one is having 3 acidic alpha hydrogen atoms, 3 alpha hydrogen atoms, that is being acidic, and it is having 0. So perfect. This much is clear. If this much is clear, my dear friends, you are rocking. Now see kids, the famous reaction which every student knows. This is the famous reaction. The first example I am going to deal with aldol condensation, famous reactions, famous example, or the basic example, famous example. All the time, everyone used to give 2 moles of CH3, CH double bond O on reaction with dilute NaOH and heat. So CH3, CH double bond CH double bond O, and the name of compound is crotonaldehyde. Now, my dear friends, this is the famous reaction and famous example. In the school, every kid knows and every teacher is going to teach this example. Are you getting my point? Now, my dear friends, how this reaction is going to take place, what is the mechanism, and what is the short trick? First of all, do let me know, should I tell you the short trick first or the detailed mechanism? Kids, it's your time. Do let me know. Should I start with the short trick first or the detailed mechanism? Hey, everyone, do let me know. The ball is in your court right now, my dear friends. Detailed mechanism. Oh, my kids, you are really rocking. That's really fantastic. Something very good. Nice. Now, see, kids, mechanism. Let's deal with the mechanism first. And you have to tell me the mechanism. Mechanism. Now, just try to understand, my dear students. You have to develop the thinking. Suppose if I'm saying there is one beaker, and in this beaker there is NaOH, there is acetaldehyde. What do you think? Who will break first? This is dilute, that means water is also there. Water is also there. HOH is also there because this is dilute or concentrated, whatever. These three type of entities are there. A, B, C. What do you think? Which will break first? Kids, if I'm telling you each and everything from here, that means you're not opening your brain. This is the time to make your brain broad. Just listening is not important. Just you have to open your brain, my dear friends. NaOH is reactive because this NaOH is having ionic bond. This is having ionic bond. So this will break first. Very good, kids. Very good. Really, I like your thinking. So it will break like Na positive, OH negative, right? Now, this OH negative can behave as base as well as it can behave as nucleophile. It is having two roles, so that it can behave as a base or it can behave as a nucleophile. So whenever the entity is having two types of choices, which reaction will be dominating, acid base or nucleophile electrophile? So always whenever an entity is having two choices, give preference to act as base. It will get preference to act as base. Now this base is in search of what? This base is in search of acidic H. Acidic H. So it will approach this acetaldehyde. Now kids, see, this acetaldehyde is having three acidic hydrogens. So the base will come and approach over here. This OH negative will come and will say, hey, I want to take your proton. I like you right now. So H plus is going, oh, please come over here. Inge ba, ibde ba. Now this OH negative saying, oh, let's move. I want to go. Let me go. I want to go. I want to go. So because this is acid base neutralization and this is strong base and this is weak acid, and that is being strong base, so reaction will lie in equilibrium, and you are going to get carbon ion CH2 negative CH double bond O. So this carbon ion got formed. Kids, are you getting it? Now, once this carbon ion is formed, dipole is there. And once the dipole is there, dipole, induced dipole will be there. The two molecules we have taken. So this was the first molecule. And the second molecule will act like this. O delta negative, delta positive. Because this negative charge will develop dipole over here. So this charge will move and it will be like this. CH3, CH positive, O negative. My dear friends, can you see? This negative and this positive. Positive and negative. One carbon is having negative charge. Another carbon is having positive charge. So do let me know what is going to happen, kids. Everyone do let me know. This carbon is having negative charge and this carbon has developed positive charge. What will happen? So both the carbon will say, oh, I need you right now. Let's form a bond. They will start forming a bond, kids. Everyone, can you get it? Bro, carbon, new bond formation. Can you see, kids? The examiner will ask that in which reaction the carbon new bond formation takes place. So what should be your answer? Carbon new bond formation will take place over here. Kids, till now everything is clear. Just do let me know this thing I am telling you, or you yourself able to understand. Kids, do let me know this much your HSP Baba is telling you, or you can understand by yourself. First of all, do let me know. Kids, completing syllabus doesn't mean anything. I'm here to tell you each and everything, whatever the knowledge I have given to you, the basic. Everyone used to say that, oh, it's very tough organic. I say no. Chemistry padikya radu kastama. No, elle. It's romba sulbham. Shivakumar is saying last step alone. Can you tell me, sir? Oh, this step. Let me tell you in detail. Okay, see. This step I am going to tell you over here. Just see to it. This is carbonyl CH2 negative CH double bond O. It will do resonance. You know, if resonance it is doing, it will look like this. Enolate CH2 double bond CH O negative. Enolate. Now, the second, you know that one more acetaldehyde is there. CH3 CH double bond O. It is always like this only, negative, positive. So you can see this carbon is having negative charge and this carbon is having positive charge. This is new bond formation. Carbon new bond formation. Everyone do let me know. Carbon new bond formation. Now, after this, let's see what we will get. We will see this compound has become like this. Just see to it. This is your CH3 CHO negative and it has formed the bond. So see CH2 CH double bond O. So this is right now carbon new bond formation has taken place. Everyone do let me know. Till now, is it clear? Is it clear to each and everyone? Thank you, Shakti Ganesha. Thank you. Now, from water, as water was there, it will take H positive from here, and Na positive will be like NaOH. This is delta negative, and it will take H plus from here, kids. Now, after taking H plus, this compound will be like this. Just see to it, everyone. This compound will look like CH3 CHOH and that CH2. I'm using different colors so that you can understand easily. CH2 CH double bond O. Can you see, kids? Everyone do let me know. Can you see? Now, kids, this is aldol. This is actually aldol. What is the identification of aldol? Aldol is always, see, this is carbonyl group, this is alpha carbon and this is beta hydroxycarbonyl. Beta hydroxy carbonyl. This is aldol's identification. Aldol is always beta hydroxy carbonyl. That is beta hydroxy, either aldehyde or ketone. So remember that. What is aldol? If anyone is going to ask what is aldol, aldol is always beta hydroxy aldehyde or ketone. So my dear friends, this is aldol. What is aldol? If anyone is going to ask, it's what do you mean by aldol? So you have to say Aldol means beta hydroxy aldehyde or ketone. This is the identification. If it is not like that, that is not to be called as aldol, my dear students. Now see what I have given you. We have formed compound like this CH3, CHOH, CH2, CH double bond O. Till now, this aldehyde has lost its one acidic alpha hydrogen. So to form aldol formation, at least one acidic alpha hydrogen is required. Now, what will happen, my dear students? OH negative will come once again. First of all, let me tell you the short mechanism, and then I will let you know the detailed mechanism. Just see, in short, I would like to say that from beta, OH negative will eliminate out. So this will develop delta positive charge, and from alpha, H plus will eliminate out. So they will form water negative and the H positive. So the compound will look like this: CH3, CH double bond, CH double bond O. This is aldol condensation because water has been eliminated out, and the final product's identification is, this is always alpha beta unsaturated. So if anyone is asking what is the aldol condensation product, aldol condensation product means always alpha beta unsaturated aldehyde or ketone, and this is croton aldehyde. Now, yeah, wow, Gautam. Now, let me tell you the detailed mechanism. Arjun Singh, good morning. Wow, good morning. Arjun Singh is saying, Mankotia, I'm an old student from Chandigarh. You taught me in 2013-14, was able to secure the first government seat of my state because of you. Arjun Singh, thank you. How you got this channel, Arjun? How you have come to know about this channel? Oh my God, see kids, 2013 and 14, Arjun got, oh my God, thank you. Oh, thank you, Arjun, thank you. So nice of you, Arjun, so nice of you. Now, kids, really students means a lot. Great, see kids, old memories, gold memories. Thank you. Now see kids, let me tell you the detailed mechanism. Just see to it. CH3, God bless you, Arjun. CH3, CH, OH, CH2, CH double bond O. Still, this hydrogen is acidic. You know that we have used dilute NaOH. So OH negative will come. OH negative will come and will say, hey proton, just come along with me. I want to form a bond. So OH negative will go along with this H plus to form once again water. Water will eliminate out, my dear student. This reaction is once again reversible, and you can say this is acid-base neutralization. Once you have seen the acid-base neutralization has taken place, once again the acid-base neutralization will take place, my dear students. This is acid-base neutralization. Acid-base neutralization. Now you will get carbanion. What will you get? You will get carbanion. CH3, CHOH, CH negative, CH double bond O. This is conjugate base. Now, my dear friends, if I use one word, E1CB mechanism, this name is not in our syllabus, NEET syllabus. E1CB mechanism. If I tell you, when I was teaching for IIT, now you will say, now you're not teaching. I'm right now also teaching for IIT, my dear students. But in the IIT syllabus, even CV is now less important, and NEET examination, even CV mechanism is not there. And this is known as Arjun Singh is writing, wanted to wish all the students watching, sir, best of luck. You are being taught by the best teacher of chemistry out of there is concept and teaching kids. I would like to say thanks from the internal core of my heart, Arjun. Thank you. See, Arjun has studied in Chandigarh, that was offline coaching in 2013-14, and Arjun Singh knows very well that how many students they have gone to how many best government colleges, and that time also I was teaching like this on. Thank you kids, thank you. And Arjun Singh, thank you from the internal core of my heart, all the blessings, because old memories are gold memories. That's really awesome, sounding very good. Now my dear students, and Arjun Singh is writing, sir, has not changed a bit. See kids, these are the students. Love you. God bless you, Arjun. Oh, I'll be moving to USA shortly. All the best. I will pray to Almighty God to bless you with all happiness and prosperity, Arjun. My blessings, our channel's blessing, and God's blessing are always with you. Arjun, always with you. Thank you. Now, once this negative charge has developed, and this is known as E1CB mechanism, but not required for our syllabus. Now it has become, otherwise it will become very tough. E1CB mechanism, E1CB, but not in syllabus, but not required, not in syllabus. So out of syllabus we are not going to study. Now this negative charge will come toward this side, and there will be repulsion. Due to repulsion, this OH negative will eliminate out to give plus charge, and Na positive will take this OH negative, and now in this way you will get final product CH3 CH double bond CH and CH double bond O. This is your condensation product, kids. Now this I have told you the detailed mechanism in detail. Now if you're going with this mechanism in your examination, kids, then it will take too much time. Now let's see the short trick, HSP Baba short trick. Now see, HSP Baba short trick, kids. Are you ready to see the HSP Baba short trick? Just see to it, everyone. Just see to it. Write down one compound like this, CH3 CH double bond O, and the second molecule like this, see the acidic alpha hydrogens like this. Condensation means just to eliminate out either water or carbon dioxide or ammonia. The simple molecule should get eliminated out. Now see, these are the two molecules. You can see this is the carbonyl group and this is acidic alpha hydrogens. And what you can see, just to remove water. Water should eliminate out, my dear friends. Water got eliminated out and we got the product. Here is your product, CH3 CH double bond CH CH double bond O. This is your product, kit. See how nicely, how speedily, just within fraction of seconds we have got the product, my dear friends. Just see to it. Just see to it. Is it alpha beta unsaturated? Yes, this is alpha, this is beta, and its common name is proton aldehyde. Kids, remember that, proton aldehyde. We have seen the full mechanism along with the short trick. Now, this short trick is really very important if you want to go back. Suppose if somebody has given compound and they are asking what is the original compound. So what you're supposed to do, just to find out original compound, place here at alpha position, place 2 hydrogens and beta 1 oxygen. Give beta, to beta give 1 oxygen, and to alpha 2 hydrogens. Should I tell you one compound? And if they are asking the original product, the reactant C-kits, how they are going to ask C-kits? You know that to climb on tree, to move upside on tree is easy. It's not that easy, but comparatively to come back, to get down, it's very tough. To move upside on the mountain is easy. It's not that easy, but yes, comparatively it's easy to come back. So now see kids, how the questions they are going to ask. Sheshadri is writing, many teachers I saw they working for money, but here HSP Baba is even for free course. Also, he didn't left any topic. Dhanyavadam, Dhanyavadalu. Sheshadri, thanks. You have noticed. Thanks for noticing my best efforts, my hard work. See kids, really how much happiness I'm feeling in the internal core of my heart. I'm really accomplished. Sheshadri, thank you, thank you. Now see kids, if they have given like this, see question, just focus on the question kids. Question they have given like this. An organic compound on reaction with dilute alkali and heat, dilute NaOH and heat, has given product like this: CH3 double bond CH CO CH3. This is very famous compound. Its name is macetyl oxide. They can give you the name also kids. Macetyl. Let me write down once again, otherwise you won't be able to understand. Macetyl oxide. Now they are asking what is the organic compound, starting organic compound's name kids. How to do it? Now you are my students. I'm not going to teach you like this is reaction, this is aldol condensation. No, my dear student. I will tell you this reaction with all the angles. Number of teachers are there on YT. They can complete all name reactions just in 1 hour. But I'm here who is going to complete even aldol condensation, only single aldol condensation in 1 hour. But yes, kids, I will let you know each and everything. Oh my God. Kids, just take the pick of these comments. Really awesome comments, kids. Shiva Kumar, thank you. Really, thank you, kids. Acetone, propanone. Yeah, kids, very fantastic. Now see what you're supposed to do. This is alpha, this is beta. To beta give oxygen. Beta will get oxygen, and alpha will get 2 hydrogens, and this is your original compound. This is your answer, named as acetone. Gets acetone. Very good. Or propanone. IUPAC name is propanone. Now kids, is it clear to all of you? Now see kids, I'm going to give you one interesting question. Just see to it and watch it properly. If examiner is going to give you question like this, 2 molecules of propanol, CH3, CH2, CH double bond O. This is IUPAC name is propanol and journal name is propione aldehyde. Propione aldehyde. This is the journal name. And this is going to react with dilute NaOH and heat. So just sit with pen and copy and try to find out the answer. Then I will write down the answer and you have to say whether this is the right answer or wrong answer. Right, kids? Just do it in your copy. Just do it in your copy, and then just after 15 seconds, I will write down the answer and you have to tell me whether you have got same answer or not. Just see to it. Now, I'm going to write down the answer and you have to tell me, is this your answer? CH3, CH2, CH double bond CH, CH2, CH double bond O. Is this your answer? How many students got this answer, my dear students? Do let me know. How many of you have got this answer? Do let me know. Kids, examiner will give you 0 marks for this. Examiner will give you 0 marks for this. 0 marks, 0. Kids, 0. See, why? Just try to understand why 0 marks you are going to get, kids. Just see to it. Why examiner is going to give you 0 marks for it. See to it. What I told you, kids. This is alpha, this is beta, this is gamma. Is this alpha, beta? Is this alpha, beta? Now, teaching is very simple, kids. But in the examination, you are going to lose marks. Who is going to tell you that what type of mistake 99.9% students are going to often they are going to make over there? I'm the one who will not allow you to do any single mistake over there. Now, see, kids, this is not aldol condensation. This is not aldol condensation product. What I've told you, aldol condensation product must be always, it should always be what? Alpha beta unsaturated. So this is wrong. And after giving exam, you will say, oh my God, this was a silly mistake. Now see how to do this question. Everyone see to it how to do this question, kids. This is your CH3, CH2, CH double bond O. This is propanol. Okay. This is in need of what? This is in need of alpha acidic hydrogen atoms. This is in need of alpha acidic hydrogen atoms. So alpha acidic hydrogen atoms are these, not those. Those were beta. These are acidic alpha hydrogen atoms. In the starting, you have eliminated out beta hydrogens. You have eliminated out beta hydrogen atoms. What you are supposed to eliminate out alpha acidic hydrogen atoms. So it will eliminate out, and your product must be, kids, what? The water will eliminate out. The condensation product must be, kids, CH3, CH2, CH double bond C, CH3, CH double bond O, and just see to it. This is alpha and this is beta, and this is the correct answer. Now, kids, how many of you are able to understand? Do let me know. Now, how many of you are able to understand? Just do let me know, my dear friends. Everyone do let me know. Now, I'm going to give you another question. Just see to it. Just see to it and find out the answer. And just giving you those feelings that you are just sitting in front of me. Are you getting that feeling that you are just sitting in front of me and you are trying to understand, just like in your home, I'm present at your home and I'm teaching you individual, personal attention. Your HSP Baba is giving you, kids. Now, what type of mistakes you are going to do, I'm taking care of that also. Thank you, kids. Now, see, kids. Here is the question. Just try it out. Everyone, try it out. Yes. Now, you have to sit along with pen and copy. You have to find out the product. Then after 15 seconds, I will write down the answer. And you have to tell me whether your answer is like that only or some other answer you are getting, my dear students. Now see how I am going to do this question. I will take this carbonyl group, this molecule like this, double bond O, it must be in search of acidic alpha hydrogen atoms. So this compound is having on the right hand side as well as on the left hand side these hydrogen atoms. These are acidic because this is carbonyl group and this is being alpha carbon, and it is sp3 hybridized. So water will eliminate out in this way, and the product you will get, my dear friends, what product you are going to get, just see to it. The water is going to get eliminated out and the product will be this double bond. Now how to verify or cross check whether our answer is right or wrong? Just see to it, kids. This is carbonyl group, this is alpha, this is also alpha, and this is beta. This is also beta, but alpha beta. This is correct answer. Have you got this answer, kids? Dasrath Ramakant, Dashari Ramakant is writing no acidic alpha hydrogen. This compound is having 4 acidic alpha hydrogen, kids. To this side and to this side. It is having 4 acidic alpha hydrogen atoms. So definitely it will show aldol condensation. Got it, kids? Priyanka, you got it? Everyone, you got it, kids? Do let me know. Yeah, now I'm going to tell you cross-aldol condensation. This was same molecules were reacting. Now I'm going to tell you cross-aldol condensation. Are you ready, kids? Cross-aldol condensation. When we use the word cross-aldol condensation, when different molecules, in case of different types of molecules, in case of different types of molecules, we will use this word. I thought it was when, this happens, no problem, not at all. Now see, kids, if somebody is giving you one type of molecule like CH3CHO, oh my god, what happened? Kids, just wait for a second. So due to some technical glitch, screen has gone. Just a second. Okay, I need your So see, even sometimes computer also says, oh, I'm gone off the screen. It's now kids, just suppose think of such type of teachers who are always using slides, written slides. They can't teach without slides. Just think about such type of teachers. They can't write even a single word without slides. What would happen to them? What would happen to them, kids? This is your HSP Baba who's always using plain slides, never the written material. Kids, think of those teachers. Now they will say, oh, so due to technical glitch, now we are going to leave this class, this and that, like that. So let's see in case of different types of molecules. So see to it, kids. If anyone is going to give you a question like this, that CH3 CH double bond O plus CH3 C double bond O CH3 dilute NaOH and heat. Now kids, remember that when anything, thank you Gautam, thank you, when anything is given like this, just remember this is not one molecule. This is one type of molecule, but many molecules. You know that 1 mole contains 6.023 into 10 raised to the 23 molecules. So that means this entity's n molecules will be there, number of molecules will be there, and this entity's n molecules will be there, means number of molecules will be there, my dear friends, number of molecules. Now, if somebody is going to ask how many types of aldol condensation product you will get, what should be your answer, kids? How many types of aldol condensation products we will get? Question is how many types of aldol condensation products we will get? How many something is how many types of aldol condensation product we will get, kids? So what should be answer? What should be answer? Now let me tell you one story to get this answer, because this question is given in NCERT, even it is given in NCERT. To find out the answer of such type of questions, are you ready? Let me give you one story. Happy birthday story. Should I give you? See, let us suppose we are going to celebrate happy birthday. We have got balloons, red balloons. Let us suppose 100 red balloons we are having, and we are having green balloons, 100 green balloons we are having filled with gas, hydrogen gas, means they can fly, kids. Okay, this is tail, this is head of the balloon, this is tail, this is head. Now let's celebrate. This is a puzzle. We are supposed to solve this puzzle. Now the balloon, they can fly, they are filled with gas, they can fly and they can collide, but we have to count only those collisions, only those collisions where head and tail is colliding, head plus tail is colliding, head to tail collision. We have to consider only these type of collisions, head to tail collisions, right? Now do let me know how many types of head to tail, head plus tail combinations will be there. Just do let me know. Permutation and combination, you can simply say maths, simple maths, permutation and combination, and you can play this game. Just do let me know. Everyone, do let me know how many types of collisions are possible. Everyone, I'm waiting for your answer, kids. Yes, till now no answer. Till now no answer, kids. Head to head. No, no, no head to head. Head plus tail. Head to head is not allowed. Only head plus tail. How many? How many? Only head plus tail. How many? How many types? How many types? Do let me know. Three types. Krishna is writing three types. AB is writing two types. Let's try it out. Right now, we are just colliding balloons filled with gas. We are not dealing with science. Kids, should I let you know these are four types? These are four types. Should I tell you? Four types. Kids, should I tell you? These are four types. Now, see what are the four types. See, if I say the green balloon, its head plus its tail, green balloon's head and green balloon's tail. Now if I say the green balloon's head and red balloon's tail, if I say red balloon's head and green balloon's tail, and if I say red balloon's head and red balloon's tail, red balloon's head and red balloon's tail. So how many options are possible? Two self means green head, green tail, red head, red tail. These are self. Red head, green tail, or green head, red tail. These two are cross. So two cross, two self. Green head, green tail, red head, red tail. This is self. Means they are colliding with self. Green head, green tail. This is also self. But my dear students, these two are cross, means one's head and one's tail. Are you able to understand, kids? Do let me know. Two self, two cross. Now, let me tell you this magic of birthday party in science. Just see to it. It's, if I tell you over here, CH3, CH double bond O and two hydrogens, CH double bond O, this is self. If I say CH3, CH3 double bond O, CH, H, H, C double bond O, CH3, this is also self. Water will eliminate out. Already we have seen these two. One is croton aldehyde and one is macetyl oxide. One is croton aldehyde and one is macetyl oxide. The two products we have already seen in detail. All my dear students, are you able to understand? This is going to give croton aldehyde. Its product will be croton aldehyde, CH3, CH double bond, CH double bond O. This is known as croton aldehyde, very, very famous compound, croton aldehyde. And this is going to give macetyl oxide. It's again very, very famous compound, macetyl oxide. Macetyl oxide. Now, my dear students, these two are self. This is self because same molecules colliding. This is also self. Same molecules are colliding. Now, let's see the cross-aldol condensation. If I take this molecule's head, that means CHO carbonyl group, and another molecule's tail, that is CH3, C double bond O, CH3. The water will get eliminated out, and this is cross-aldol condensation because one is acetaldehyde, one is ketone. Now, another molecule, if I take like this, the acetones carbonyl group, and acetaldehydes, two acidic alpha hydrogen atoms, then you will get compound like this. The water will get eliminated out and you will get product like this. These two are being known as cross-aldol condensation. Is it clear? So, four types of molecules, and this question is really very important because number of times in various examinations, this question has been asked, my dear students. So, it holds a hell lot of weightage. So, I hope this is clear to each and everyone, my dear students. Clear. Now, see kids, I'm going to tell you very important reaction, very important reaction. See kids, if somebody is going to give you compound like this, CH2 double bond O plus CH3 CH double bond O, dilute NaOH and heat, Kids, first of all, let me tell you, it's not compulsory that always they are going to give you dilute NaOH only. In place of dilute NaOH, what else they can give you? Let me tell you what other things they can give you. They can give you dilute NaOH, they can give you dilute KOH, they can give you dilute calcium hydroxide or barium hydroxide, they can give you NaHCO3 aqueous. You know that if you apply ionic equilibrium, this will dissociate salt of strong base, weak acid, so it will give you NaOH, Na2CO3, they can give you Na2CO3 aqueous, they can give you C2H5ONA, they can give you RONA, they can give you KHSCO3 aqueous, K2CO3 aqueous, ROK aqueous. Now, one more thing they can give you, the very fantastic thing, they can give you even Br negative, BRO3 negative. You know that Br2 plus KOH gives Br negative and BRO3. That was disproportionation, and this is conproportionation reaction. So it is going to give you Br2 plus OH negative. So this forward direction, this is conproportionation reaction, and backside it is disproportionation, just opposite of disproportionation. This is conproportionation. So ultimately what matters, OH negative is the main thing. So in place of dilute NaOH, they can give you these many reagents. Now let's see how the reaction will proceed and what should be the answer. See kids, this compound is not having any acidic alpha hydrogen, no alpha hydrogen atom, and it is having 3 alpha hydrogen atoms which are being acidic. Now let's see what reaction you are going to get. So the one who is not having acidic alpha hydrogen atoms, its carbonyl group will combine with the one who is having acidic alpha hydrogen atoms. So the reaction will proceed like this, my dear students. It will go like this, and the water will eliminate out, and your product will be CH2 double bond CH and CH double bond O. This is your product known as acryldehyde. Acryldehyde is the general name, my dear students. Acryldehyde is the general name of this product. Now, this is cross-aldol condensation. Now, my dear students, I'm going to tell you very important reaction, that is Prince reaction. Name is not important, but this reaction has been asked 3 times in IIT examination. Now see kids. Yeah, it is HCH. Oh, sorry. Thank you. Gautam, thank you. It's not this compound. It is HCHO. Thank you, Gautam. It is like this, right? Now see kids, if this question has been asked like this, see kids, CH3 CH double bond O plus HCH double bond O, 3 equivalents. Now they have given just dilute NaOH, no heat is given. And here it's written 1 equivalent only, 1 equivalent. Now this is very special reaction, my dear students. This is very special reaction, very special reaction. Very special reaction. Better to say very special example. Very special example. Now, this question has been asked. Gautam, yeah, CH2O. CH2O is HCHO. See, Gautam, if I say CH2O, that means formaldehyde only. Either you can write like this, or you can say HCH double bond O. They are same. Right, Gautam? Either you write formaldehyde like this, or you can write down formaldehyde like this. Both mean same. Right, Gautam? Now see, everyone. This is very special example. Now, how many of you want to understand or to go along with the mechanism for this question? Just see, this is having 3 acidic alpha hydrogen atoms. You can see 3 acidic alpha hydrogen atoms, and this is having no alpha hydrogen atoms, and they have not mentioned heat. That means they are focusing on, or they would like to go with aldol formation. They are not wanting to go with aldol condensation. They are focusing or emphasizing on aldol formation. That means they want to go with aldol formation, and the option should be given like that only. So just think of aldol formation, my dear students. So for the aldol formation, we will go along with the mechanism. See, what was the mechanism? Mechanism was this, that NaOH will provide what? NaOH will provide OH negative, right? NaOH will break to provide Na positive, OH negative, right? OH negative is in search of acidic alpha hydrogen atom. So let's take one acidic alpha hydrogen atom, and this will be taken away by that OH negative. OH negative will come and it will eliminate out this H positive to form water, and this molecule will look like this: CH2 negative CH double bond O. Till now, are you comfortable? Now see, the formaldehyde will come, and you know that the formaldehyde, it's like this: CH positive O negative. Can you see this is formaldehyde, this carbon positive and this carbon negative, they will start forming a bond. Hey, my dear friend, let's form a bond. Let's form a bond. Carbon, carbon, new bond formation. Hey, everyone, are you okay? Carbon, carbon, new bond formation. Now just see to it. Carbon, carbon, new bond formation. What is going to happen over here? Everyone see to it. Carbon, carbon, new bond formation. So see to it. This is CH2, CH double bond O, and this will form a bond carbon CH2 O negative, and later on this O negative will take H plus from water, H plus from water, HOH. This H plus will come in the life of this oxygen, and this will look like this. This compound will look like this, CH2 CH double bond O. So it has lost one acidic alpha hydrogen atom, and in place of that acidic alpha hydrogen atom, it has gained what? CH2OH. In the life of this compound, CH2OH has taken entry in place of what? In place of one acidic H. This is aldol. Purely this is aldol. How to find out this is alpha and this is beta? Beta hydroxy. Just see to it. In the starting only I have told you this is alpha, this is beta, and this is beta hydroxy carbonyl compound. Beta hydroxy carbonyl compound. So definitely this is aldol. Now my dear friends, just in place of one acidic H, this compound, this acetaldehyde, has lost one acidic H and it has gained one CH2OH. Now the same thing it will do twice, because it is having two more acidic H, so twice more aldol formation. Are you able to understand? Whatever the thing this compound has done once will be repeated twice more aldol formation with, because in the starting you can see 3 equivalents of HCHO was given and only 1 equivalent of CH3CHO. So in place of these 3 acidic H, we will get 3 CH2OH, 3 CH2OH. Now see kids, what we are going to get? 3 CH2OH. Now see, the compound final product will look like this, CH double bond O, and we will get 3 CH2OH, 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 CH2OH. Either you can write this compound like this. Why this line is there? Just a second kids, where this line, yeah, go on. Now see kids, this product can be written like this, or you can write this product like this. See kids, very very important name reaction. So I am writing the product once again, because probably most of the students will not be able to do this question in the examination. So this question is really very very important. So the product with dilute NaOH will be like this. See kids, CH3 CHO has converted into what? Just see over here. So this is carbon, my dear students. This is carbon, and what I have written, just see. On one carbon, CH2H, 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 3 CH2OH I have written. So see, this is CH2OH, CH2OH, CH2OH. This is the product kids. Is everyone able to understand? I think that you have become bored. You got both kits, or you are able to understand each and everything. Just to let me know. Is it clear to all of you? Are you comfortable? Everyone is comfortable, kids. Is everyone comfortable, my dear students? Now, I'm going to start with intramolecular aldol condensation. Intramolecular aldol condensation. Just see to it. Intramolecular aldol condensation. Kids, you must be thinking, sir, 1.5 hours is about to go. Why this is not three equivalent, right, sir? Emma, what are you asking? I am not getting it. Three equivalent we have used. See, we have used three equivalent. Just see, 1, 2, 3 formaldehyde. The same question. Oh, you must be asking, it's not written. Let me write down three equivalents, and yeah, one equivalent, right, Hema? This is one equivalent. Same question I have written in this form. That's why I was telling you this is the best way, nice way of writing. Okay, Hema? Now, intramolecular aldol condensation. Okay, I got it. Thank you. Now see, kids. Within the molecule, intramolecular means what? Intramolecular means within the molecule. Within the molecule. But remember that everyone, 6-membered ring is more stable than 5-membered and little less than 7-membered. This is the stability of ring, kids. Ring stability. Now, if somebody is going to give you compound like this, just focus over here. If somebody is going to give you compound like this, CH double bond O, CH double bond O, dilute NaOH and heat. Now, kids, just think over it. What can you correlate? Gautam is saying HCHO. Gautam, see, even if one is having, suppose two kids are there, if both the two kids, they have brought their lunch, then both will enjoy. And if both are not having tiffins and lunch, then they can't have their lunch. But if one kid is having tiffin, another one has not brought the tiffin, then what will happen? Then also they can enjoy by sharing. See, kids, one is having 3 acidic alpha hydrogen, one is not having. So kids, only one is donor of alpha hydrogen, another one is acceptor of that. So it's not necessary that in cross-aldol condensation, both the two type of molecules, they should have acidic alpha hydrogen atoms. Even if one is having acidic alpha hydrogen atom, then also they will undergo aldol condensation. Got it? So any of the reacting species entity is having acidic alpha hydrogen atom, then also they will undergo aldol condensation. Now see, kids, this is the molecule. Now see how many acidic alpha hydrogens are there in this molecule. This is carbonyl group, 2 acidic over here and 2 acidic alpha hydrogen atoms at this place. Now, should I start telling you how many carbons we are having? 1, 2, 3, 4, 5, 6 carbons we are having. Just try to understand how I am going to tell you now. See, wow, Hema, fantastic, really fantastic answer. See, Hema has given the answer. Just see to it, kids. If I draw one hut, two huts, and third one was like this. This was CH double bond O, and this was also CH double bond O. So in the just very fast manner, we can make it like this carbonyl group, and that alpha hydrogen atoms, if they are eliminating out, you will get ring of how many carbon atoms. Just see to it. If I say the A, B, C, D and E, this is the ring in between A and E. How many carbon? 1, 2, 3, 4, 5 membered ring. Can you see, kids? 5 membered ring. Now we got 5 membered ring, and we can say this is 5 membered ring. And any carbon you can call it A, B, C, D like that. It's your choice. It's totally your choice. So let us suppose I am calling it A, B, C, D, E. You can write from anywhere A, B, C, D, E. Now, my dear students, the bond is formed between A and E. A and E, there is bond formation. So I have written double bond O because this is one more bond. One bond was already there. This is another new bond. Now, on E, I have to place CHO. On E, I am supposed to place CHO. So I have written CHO. Kids, nothing else is required. Just try to understand, is this the correct product? C, alpha beta unsaturated. So this is your answer. This is your answer, kids. Got it? Sir, why we did not take alpha hydrogen from B? You can take from this, then this carbonyl group would have reacted C. Gautam, if I have taken this CHO and this acidic H, C, then also we'll get the same product. Just see to it. If I have done it like that, if I have eliminated out water in this way, then also I must have got the same product. This product only I will get. Either way you go, you will get the same product. Just see to it, kids. Got it? Everyone got it, my dear friends? Do let me know that you are able to understand it. So this is your answer. Got it. That's really fantastic. That's really fantastic. Now see, kids, see to it, everyone. Now, I've told you each and everything about aldol condensation. Now let me tell you one very, very important point or note about aldol condensation. Just see to it, everyone. If anyone, so let me tell you special points, kids. Special points about aldol condensation. Just see to it. If somebody is going to give you compound like this, CH3, CH double bond O plus concentrated NaOH. Concentrated NaOH. What's new, kids? You must have studied acetaldehyde with dilute NaOH number of times, but focus over here. They have given concentrated NaOH. This is the point to be noted, my lord. Very, very important point. Whenever concentrated NaOH is given, remember that repeated aldol condensation will take place. What will take place, my dear friends? Repeated aldol condensation will take place. Repeated aldol condensation will take place. Now, what is that? My dear friend, just see to it. Once we have done aldol condensation, we got product like this croton aldehyde, CH3, CH double bond, CH, CH double bond. Oh, this was croton aldehyde. Once again, because this is concentrated. Concentrated means again and again the aldol condensation will take place because this is in too much amount. So once again, this crotonaldehyde, this is crotonaldehyde, this will react with acetaldehyde, and once again the water will get eliminated out. Now my dear students, what we will get, just see to it, we'll get product like this, CH3, CH double bond CH, and once again CH double bond CH and CH double bond O. You can focus over here. This CH double bond CH will keep on repeating. This will keep on repeating and this will keep on repeating, my dear students. So finally we will get compound like this, CH3 CH double bond CH, because this is a repeating unit, and CH double bond O, and this is a polymer, kids. This is polymer, and this polymer is known as brown resinous mass. Brown resinous mass. This is very, very important, and it is missing in NCERT. This thing is missing in NCERT, and number of times it has been asked in your NEET and JEE examinations. Gets clear to all of you. This is polymer. Krishna, welcome. Krishna, welcome. Now, kids, the second important point I am going to tell you. Are you ready, kids? Everyone ready? Now see, the second important point is aldol condensation in acidic medium. This is very, very important. Aldol condensation in acidic medium. Have you heard this? Aldol condensation in acidic medium. Now, my dear friend, this is missing in NCERT. First of all, let me tell you, missing in NCERT, but important for all the examinations. Missing in NCERT. This is missing in NCERT. And this aldol condensation in acidic medium is mainly used for ketones. As you know that ketones are very, very less reactive. So this thing is mainly used for ketones, because we know that ketones are less reactive. This is mainly used for ketones because for ketones equilibrium lies in the backward direction. Why in the backward direction, kids? Because they are less reactive. As we have seen in nucleophilic addition reaction, ketones are less reactive. So for the ketones, the equilibrium mainly goes shifted in the backward direction. Now see, kids, there are just two examples. You have to keep those two examples in your brain and missing in NCERT. Just see to it. If we react acetone, plus dry HCl, we will get two products, means two types of products. One is macetal oxide, another one is boron. You just remember phone. You can remember phone, and in phone add rho, so it will become boron. Boron is a polymer and it is major product. One thing you have to remember, this thing. This is really very, very important, my dear students. It's really very, very important. Now, you must be thinking how it is formed and what is this, how to remember the product. Just see to it. If I react molecules of acetone like this, CH3, C double bond O, CH3. If 2 moles are reacting, what will you get? If 2 molecules of acetone are reacting, what will you get, kids? Definitely we will get methyl oxide in this way. CH3, CH3, double bond CH, C double bond O, CH3. Its name is very famous compound, methyl oxide. Now, my dear friends, if 3 molecules are reacting, because dry HCl will make 3 molecules to react. See, CH3, CH3, C double bond O, 1 molecule, C double bond O, CH3, CH3, 2 molecules, C double bond O, CH, H, H, CH, H, H. Now these are reacting. So water will eliminate out from here. Water will eliminate out from here. Now 2 molecules of water will get eliminate out. Now my dear friends, the product you will get, that will be phoron. Now see how the phoron will look like. CH3, CH3, C double bond CH, C double bond O, CH double bond C, CH3, CH3, and this is phoron. More than 2 molecules, it is known as polymer. This is phoron. It's clear to all of you? Is this being clear to all of you? Just to let me know. Are you able to understand? Now, one more reaction of acetone which is being missing in NCERT. So let's see what is that reaction. Everyone see to it. If the molecule is given like this, that acetone CH3, C double bond O CH3 is going to react with concentrated H2SO4. You know that concentrated H2SO4 is having a strong affinity for water. Strong affinity for water. We know this. Strong affinity for water. So it will eliminate out 3 molecules of water. 3 molecules of water, and it will form methylene. Methylene. Now, my dear friends, let me tell you one thing. It's near about more than 1.5 hours, and you must be thinking, sir, till now you are not able to complete even a single name reaction. That is only aldol condensation. In this much of time, many teachers, they complete the whole name reaction, and you are just dealing with aldol condensation only. Let's see how much important aldol condensation is, or other name reactions. If somebody is saying that I'm going to complete all name reactions in just in 1 hour, that means they're not doing justice with you and with the syllabus. Completing doesn't mean that just complete it. Yeah, that's really fantastic. Now see how the acetylene is going to get formed. See kids, if I'm taking 1 molecule of acetone, see like this, CH3, C double bond O, CH3. This is first molecule. The second molecule of acetone I am taking like this, CH. It is cyclic because we have to eliminate out 3 molecules of water. Second molecule is like this. The third is CH, H, H, C double bond O, CH, CH. So C double bond O, CH3. So something is missing. CH3. I should place CH3 over here. Now see how many molecules of water can eliminate out. 1 molecule, 2 molecules, 3 molecules of water has been eliminated out, and in this way what I'm going to get, see kids, I will get compound like this, double bond, double bond, double bond, CH3 over here, CH3 over here, CH3 at this place. So my dear friends, never get confused with mesitylene and mesytyl oxide. Just see, this is mesytyl oxide, it is having oxygen. How to learn it, how to cram it? Oxygen, so oxide, it is having double bond in mesitylene. Can you see? Mesitylene, mesitylene, everyone. Now, each and everything I have told you about aldol condensation. Now we can have one glass of water and then I will let you know Claisen condensation. But one thing is left about aldol condensation, cross-aldol, and that is Claisen-Smith reaction. Before having glass of water, let me tell you that also. Very famous example of cross-aldol condensation. Very famous example of aldol condensation, that is Claisen-Smith reaction. Claisen-Smith condensation. Claisen-Smith condensation. Now let's see to it, my dear student. It is very important. Benzaldehyde plus acetaldehyde should be given like this: dilute NaOH heat. It should be given like this. If you see, this is not having alpha hydrogen and that is having alpha hydrogen. No alpha hydrogen, 3 acidic alpha hydrogen atoms. So this is aromatic, that is aliphatic. Now see what is going to happen and how the reaction will take place. This benzaldehyde, now many kids must be thinking there it was written at the top and here at ortho. My dear friends, in benzene all carbons are equivalent, so neither is right now ortho or meta or para. Now 2 acidic alpha hydrogen atoms, water will eliminate out. See, water will eliminate out, my dear friends. This water will eliminate out and the product will be C6H5CH double bond CH double bond O, and this is known as cinnamaldehyde. Wow, Hema, you are really very good. Fantastic. This is cinema plus aldehyde, that is cinnamaldehyde is the product. Cinnamaldehyde, my dear friends, cinnamaldehyde. Now, my dear friends, so have a glass of water. To have a glass of water, what time is required? Kids, 5 minutes, 2 minutes or 3 minutes? Everyone, Betha Janani, very good. Hema, very good. Everyone, let's have a glass of water or one banana or one apple. For that, how much time is required? Kids, do let me know. 10 minutes are sufficient. 10 minutes are sufficient. So, let's have 10 minutes break. Then we will come with Claisen condensation. We'll come with Claisen condensation. Okay, kids? Missing in NCERT, Claisen condensation. after 10 minutes break. So right now it's 12:18. So let's meet at 12:30. Okay, kids. Is it fine, kids? Yeah, definitely I will take Gotham. Definitely. Definitely. So you have to come back with original form, high energy, have some fructose, all my molecules. Let's meet at 12:30, right, kids? Okay. Hey, all my dear friends. Kids, how is everyone? Welcome back again to your Unacademy NEET English channel. This is your HSP Baba teaching for the last 23 plus years. Produced many ranks. If you're new to this channel, and really fantastic, my dear friends, I can see the likes and I'm punctual, kids. You see my punctuality because whenever I'm telling you punctuality is required, perseverance is required, regularity is required. Same thing is from my side also, my dear friends. So each and everything is required from our side also. So I'm going to start with Claisen condensation, my dear friends. This Claisen condensation is missing in NCERT. Wow, thank you, my dear friends. So many students are that much happy that everyone is writing sir is back. So they are feeling really happy, my dear students. That's really fantastic. Wow, it's so much glad you are. Now, Claisen condensation. Let's see Claisen condensation. The best example of Claisen condensation is given in most of the books. That is, let me tell you, kids, Claisen condensation. Claisen condensation. So, what is required for Claisen condensation? That two molecules of CH3, COO, C2H5, that is ethyl acetate. Ethyl acetate is the common name and its IUPAC name is ethyl athenoate. Ethyl athenoate. This is the IUPAC name. On reaction with C2H5ONA and heat, C2H5ONA and heat. This is an ester with acidic alpha hydrogen atoms. This is an ester with acidic alpha hydrogen atoms. At least one acidic alpha hydrogen atom is required. So this ester with alpha hydrogen atom, and its alpha hydrogen is not that much acidic, very less acidic alpha hydrogen atom it is. That I will let you know in detail in the next page. Very less acidic. Why it is less acidic, I will let you know. That's why heat is required and time is required. It will take time up to 6 hours to take this reaction, to carry out this reaction, for this reaction to take place. Now, kids, what it is going to form? The product will be CH3, C double bond O, CH2, COO, C2H5, C2H5. This is the product. Why three colors I have used in this? Let me tell you. This is ethyl. This yellow is being aceto because this name is very important, and the green one is acetate. Ethyl acetoacetate is very famous name. This name is very famous, and the product you can see, this is alpha, this is carbonyl group, this is alpha, and this is beta ketoester. Beta ketoester is the product. Now, most of the time the students, they are not able to remember this. Now see, kids, from ester to beta ketoester we are getting, from ester to beta ketoester we are getting. So my dear student, just see to it. What I am writing, what I am going to tell you, just see to it, everyone. This is ester, CH3 COOC2H5 on reaction with C2H5ONA, we are getting beta ketoester C2H5ONA. If I write down the product is like this: CH3 C double bond O CH2 C double bond O OC2H5. What can you see, kids? What can you see? This is alpha carbon because this is carbonyl group. This is alpha and this is beta ketoester. Now you must be thinking how this reaction has taken place and why this reaction is that much important. So what Shiv Kumar has written, Shiv Kumar, what happened, Gautam? Now everyone is able to understand. Do let me know first of all. Now, how this reaction is going to take place, let's see. And what's the mechanism? First of all, I am going to tell you in short, the short trick, because that will be very, very important. And then I will tell you the detailed mechanism. Just see to it. This is CH2H COO C2H5, one molecule. The second molecule will be like this: CH3 C double bond O OC2H5. My dear students, in aldol condensation, water has eliminated out, but in Claisen condensation, ethyl alcohol will eliminate out. Who is going to get eliminated out here? Ethyl alcohol. This H plus will go along with this O negative like this. So what will you get? Just see to it. What are you going to get? CH3 C double bond O. This is new bond formation. Just see, carbon carbon new bond formation. Once again, in aldol condensation, carbon carbon new bond formation has taken place. Here also carbon carbon new bond formation has taken place. This is your product. Can you see, kids? Is it clear? This is self Claisen condensation. Sir, you didn't taught electrophilic substitution. So Shadri, you can see hydrocarbons, aromatic hydrocarbons lecture. You just watch that, then you will see ESR. But yeah, ESR of different compounds like phenol, halobenzene. Yes, I will take one class on that. But yes, ESR's general mechanism I taught in aromatic hydrocarbons. You can see that. Then definitely, if you're not getting that, I will take lecture. Okay, don't worry. And thanks for reminding me. Okay, Shashadri, don't worry. Now see, kids, how this reaction would have taken place and why the hydrogen is not acidic. Let me give the answer. Why this ester's hydrogen is not acidic? Reason for less or very less acidic nature of alpha hydrogen in esters. Alpha hydrogen in esters. Just see to it, kids. This is our ester. This is alpha hydrogen atom. If suppose C2H5O negative is going to withdraw this H plus, this molecule will look like this: CH2 negative C double bond O C2H5. You just see the pi bond of oxygen is doing resonance with this oxygen's lone pair. You can say it is busy with this. They are doing resonance. So this negative charge is getting less chance for resonance because this oxygen and oxygen resonance is better than oxygen's carbon's resonance because energy difference. So this resonance is better. So this will remain bit localized. It will remain bit localized. So this reaction will go more in the backward direction, less in the forward direction. That's why this hydrogen is very, very less acidic hydrogen. Are you getting my point? And that's why esters do not tautomerize. And that's why this is very, very special case of condensation. Now kids, this much everyone is getting? Yeah, that's why esters do not tautomerize. This is the reason. Now see, this carbon ion is formed and its mechanism is just like aldol condensation. I have told you in the starting only, if you are able to understand aldol condensation, you can do any reaction and any mechanism. Just see, one carbon ion has been formed. One molecule has formed carbon ion. This carbon ion, see H2 negative, although this is formed in very, very less amount, yield is not good. Another molecule will act as carbocation. Just see CH3, C positive, O negative, OC2H5. Till now it is exactly same as aldol condensation, exactly same as aldol. Now in aldol condensation, the fourth step was carbon-carbon new bond formation. Here also new step, this is carbon-carbon new bond formation. Can you see? Carbon-carbon new bond formation. Now my dear students, you can see they will join together. Once they are going to form the bond, what you will see, you will get it like this: CH3 C OC2H5, this O negative, and this new bond has been formed. New bond has been formed in between these two molecules. The CH2 COO C2H5. Now kids, till now everything is same like aldol condensation, but the twist is over here in the next step. With Na, this will eliminate out. In place of water, this compound will eliminate out, this compound, or you can say this O negative, or leave Na because water is there. So I can say with HOH, this will eliminate out, and what it is going to form, this will form ethyl alcohol. So it will form ethyl alcohol, and this carbon positive and negative, they will form a bond, and this will look like CH3 C double bond O CH2 COO C2H5. This is the product and this is the mechanism. But the short trick which I have told you, that holds a lot of weightage, my dear students. So let's see the cross Claisen condensation, and we will apply the same mechanism. Let's see we are able to do it or not. Cross Claisen condensation, cross Claisen condensation. Now let's see, if one molecule is provided like HCOO C2H5 and another molecule is like CH3 COO C2H5 in presence of C2H5ONA, heat. Let's see, this molecule is without alpha hydrogen and that is having alpha hydrogen. This is without alpha hydrogen, and that is having, yes, alpha hydrogen is present. Now our target is to remove alcohol. In aldol condensation, our target was to remove water. Here our target must be to eliminate out alcohol. Just see how to eliminate out alcohol. This molecule is without alpha hydrogen, so it cannot eliminate out its alpha hydrogen. That is having alpha hydrogen, so take its acidic, that is very, very less acidic, but yes, little bit only, but yes, acidic hydrogen. And this molecule you have to keep like this. H C double bond O O C2H5. Now you can clearly see how to eliminate alcohol. Just remember, this molecule is having H, so it will lose its proton and it will lose its oxygen. So from here, the alcohol will eliminate out. Can you see, kids? Can you see, everyone? Now let's see what product we are going to get. We will get product like this: CH2 COO C2H5, and this CHO will be there. This is your product. This is alpha, this is beta. So this is the product for Claisen condensation, that is cross Claisen condensation. Is it clear to all of you? So Claisen condensation, I have told you. Now I have to tell you Cannizzaro reaction and then ozonolysis. How's the Josh, guys? Hey guys, hey my dear friends, just to let me know how's the Josh. Everyone, do let me know how's the Josh. Kids, yes, how's the Josh? Very high. I want everyone with full of Josh, Veera level. Yeah, that's really awesome. That's really awesome. Vedha Janani, yes, I want to see some fire in the chat section. I want to see some fire in the chat section, kids. Yes, I want to see some fire in the chat section. Yeah. So let's welcome our Cannizzaro reaction. Jaro, Cannizzaro. Everyone, let's welcome Cannizzaro reaction. Hey, my dear friends, let's welcome Cannizzaro reaction. Cannizzaro, suswagatam. Welcome, welcome Cannizzaro reaction. Welcome Cannizzaro reaction. Cannizzaro, Jaro, Cannizzaro reaction. 15 star reaction, very important reaction. So 15 star, we are going to give 15 star to this reaction, and this reaction is really very important. So how many stars? 15 stars to this reaction. This reaction is very important. Cannizzaro reaction. So what is required for this reaction, my dear students? Aldehyde without alpha hydrogen atom and concentrated alkali, that is 50% concentrated, or it can be written as 50% dilute. That also means concentrated up to 99%. It can be 99% concentrated. So concentration is required. So is everyone ready? Oh wow, Shukla Kumar, Vedha Janani, no alpha hydrogen, Sarvesh, very good. Now see, kids, everyone see to it. We are going to start with Cannizzaro reaction. Let's see, my dear friends. This Cannizzaro reaction is also known as redox reaction. It is also known as disproportionation reaction. Now in this reaction, the molecule who is not having alpha hydrogen atom, RCH double bond O, without alpha hydrogen atom, on reaction with concentrated alkali will form RCH2OH plus RCOONA Rexona. So one carbon is undergoing reduction, another carbon is undergoing oxidation. This is primary alcohol formation and sodium salt, sodium or potassium salt of carboxylic acid. Now let's see this reaction in detail. Is everyone ready, kids? Yeah, that's really fantastic. Now see, kids, everyone focus over here. First of all, let me tell you what is the oxidation state of carbon in aldehyde. Just focus over here. Oxidation state. Let's focus on oxidation states. Otherwise, we will not be able to understand oxidation reduction. Oxidation state is the key for oxidation. Just this is aldehyde. This alkyl group is donating electrons. So this is plus I. So it is losing one electron. This is minus I. So it is withdrawing two electrons. Now let's see. It is losing. So plus 1. It is gaining. So minus 1. It is gaining, so minus 2, it is losing, so plus 2, and hydrogen is donating, so plus 1, and it is gaining, so it is minus 1. See, kids, minus 1, plus 2, minus 2, plus 2, the oxidation state is coming out to be 0. So in aldehydes, the oxidation state of carbon is 0. Now let's see. In alcohol RCH2OH, just focus over here, RCH2OH. So plus 1, plus 1, plus 1. So plus 1, plus 1, plus 1, minus 3, and minus 1, so plus 1. So overall the oxidation state is coming out to be minus 2. In alcohol, the oxidation state of carbon is minus 2. Okay, my dear friends. Now let's see. R C double bond O O N A. Just focus over here, my dear friends. Plus 1, minus 2, minus 1. So minus 2. Minus 2's contribution over here, minus 2, so plus 2, plus 1, so minus 1, minus 1, so plus 1. So this is cancelled out, plus 2. So in this is plus 2. So what can you see, my dear students? How can you judge it, Cannizzaro reaction? So see to it, everyone. If I write down RCHO, is converting into two compounds, RCH2OH, RCOONA, concentrated NaOH. Now let's see. If we talk about oxidation state, here it is 0, here it is minus 2, here it is plus 2. Now see to it, my dear students. In this 0 to minus 2, this carbon is undergoing reduction. Here 0 to plus 2, the carbon is undergoing oxidation. So can you see one thing? Same carbon is undergoing oxidation as well as reduction. When the same atom undergoes oxidation as well as reduction simultaneously. Karan Chavla, thank you. Wow, from Shimla. 1920 Scorpio lover from Rajasthan. Thank you, kids. Thank you. Oh my God, from all over India, people are there. Bangalore, Shukla Kumar. Oh my, great kids. This is really India. Now, this is redox reaction, disproportionation reaction. That's really fantastic. So this is Cannizzaro reaction. Now, my dear students, on the basis of this, I'm going to give you three type of reaction, and then I will let you know the mechanism. So is everyone ready, my dear students? See, first of all, the reaction is 2 moles of formaldehyde. You have to complete the reactions, okay? It's your time to complete the reaction, to find out the products. Everyone help me. Concentrated NaOH. So product will be, consider this to be R, my dear friends. Just consider it to be R. This H is R. Just consider it to be R. So we'll get HCH2OH plus HCOONA. Now, in place of this, if it is given benzaldehyde, 2 moles are mentioned or not, doesn't matter. 2 molecules of benzaldehyde, same reaction, concentrated NaOH, we will get benzyl alcohol. Names are also very important. Benzyl alcohol plus sodium benzoate. Benzyl alcohol plus sodium benzoate. Sodium benzoate used for making pickles, used as preservative. Now, my dear friends, if we are going to deal with cross Cannizzaro reaction, these are self Cannizzaro reaction. We are going to deal with cross Cannizzaro reaction. Just see kids what we are going to get. 1 molecule of benzaldehyde, when allowed to react with 1 molecule of formaldehyde. Now, during cross Cannizzaro reaction, my dear friends, during cross Cannizzaro reaction, one thing is very important, that more reactive compound will undergo oxidation. This is more reactive. So more reactive will undergo oxidation and less reactive will undergo reduction. Now question arises, why sir? We have to cram it, or is there any reason? So everything has got reason. How many of you want to understand what is the reason, kids? Now, number of questions are arising, kids. First question, why only aldehydes shows Cannizzaro reaction? Why not ketones? Second, why only aldehyde undergoes? The more reactive aldehydes, they are undergoing oxidation, and the less reactive is undergoing reduction. Why the concentrated alkali is required? These are the questions which are definitely must be arising in students' brain. So let's see the mechanism for this type. So let's deal with the mechanism, my dear students. Mechanism of this reaction. Mechanism for Cannizzaro. So let's take RCHO without alpha hydrogen atom. It is not having alpha hydrogen, no alpha hydrogen atom. So we are going to use OH negative. So you know very well this OH negative would like to act as base, and this OH negative must be in search of acidic H. If there is no acidic H, so it will act as nucleophile, because there is no acidic H. So it has to act like nucleophile, and this will go and attack on this carbon. And to carry out this reaction in the forward direction, we need high concentration. Otherwise, this reaction will go more in the backward direction. If the concentration is more, then only the reaction is going to more in the forward direction. Le-Chatelier's principle. Le-Chatelier principle says if any reaction is in equilibrium, then supply more reactants concentration to carry out more in the forward direction. Yeah, mechanism is important. Mechanism of this reaction is important. Then this molecule will definitely form compound like this, RCHO negative and OH. This compound. Remember that in case of different aldehydes, the OH negative will attack on more reactive one. If they are same, then no problem, not at all. There is no choice. But suppose if I am taking one molecule to be the formaldehyde, another molecule to be the benzaldehyde, OH negative will react on more reactive, that is formaldehyde. And see, the one who is attacked by OH negative, what is going to happen to him? See kids, let me take another molecule of aldehyde, RCH double bond O, and when this is having negative charge, this OH negative charge has gone, because negative and positive, they have formed the bond, so there is no charge. So this molecule will change into like this, RCH positive O negative kids. Now see, this carbon is having positive charge and oxygen is having negative charge. It's not like aldol condensation, because in aldol condensation, one carbon was having positive charge, another carbon was having negative charge. So there was new bond formation in between carbon and carbon. Same was happened in Claisen condensation, but here it's totally different. See kids, carbon is having positive charge, oxygen is having negative charge. This bond is not going to be stable. So one thing, very peculiar thing, important thing is going to happen. This molecule will lose its hydride. It is going to donate its hydride, and you know that hydrogen with a negative charge is localized, is highly unstable. So this is very, very tough process, and that's why slowest step, and slowest step is always rate determining step. This is slowest step and this is rate determining step, that the hydride transfer, remember that it's hydride transfer, hydride transfer. This is slowest step. If I apply chemical kinetics, then how many molecules are involved in the rate determining step? 1, 2 and OH negative. So R is equal to K concentration of aldehyde power 2 and OH negative power 1. So it follows third order chemical kinetics. So order of reaction is 3. Order is 3. Third order chemical kinetics. It is following third order chemical kinetics. Now see, my dear student, what is going to happen? This is going to donate hydrogen. If it would be ketone, you know that ketones don't have hydrogen attached directly to the carbonyl group. So ketones cannot donate hydrogen. So ketones can't be hydride donor, and that's why they cannot give Cannizzaro reaction. And if these two molecules would have been different, then the OH negative would have reacted with more reactive aldehyde, and the one who is attacked by OH negative, that is the more reactive one, is hydride donor, and loss of hydride is loss of electron. Loss of electron is oxidation. So this molecule is undergoing oxidation, and this molecule is undergoing reduction. So I hope that this thing is very much clear to all of you. Why only aldehydes can give Cannizzaro reaction? First point. Second point, why concentrated alkali is required? Because Le-Chatelier's principle says that more the concentration of reactant, more the reaction will go in the forward direction. Third point, in case of different molecules of aldehyde, why only more reactive will undergo oxidation? Because the more reactive will attacked by OH negative, and the one who has been attacked by OH negative, definitely that will lose its hydride and that will undergo oxidation. Now see, after accepting this H negative, this molecule will convert into like this RCH2O negative, and that after losing will convert into R COO or C double bond O OH. So after some time it will donate its proton to this molecule. This will become alcohol and that will become salt of carboxylate. Clear to all of you, my dear students? Is it clear? So this is the mechanism. Now see, let's see intramolecular Cannizzaro reaction. Intramolecular Cannizzaro reaction. Suppose you are provided with molecule like this glyoxal. Just see to it, glyoxal. And the concentrated alkali is required. Concentrated alkali. Now kids, what will happen? One molecule will undergo oxidation. One molecule will undergo reduction. Now you see, it will not follow third order chemical kinetics. It will follow second order chemical kinetics. Why? See, this molecule is same and that molecule is same. So it will follow second order chemical kinetics. Why? Because they are not different molecules. They are not two different molecules. They are same molecule, right? They are same molecule. Now, my dear students, let me give you one awesome example of intramolecular. This is C. Although this is ketone and this is aldehyde, but see, just to donate hydride, only one molecule should have hydrogen. Now it's given like this. What should be the product? Just see, this is having H to donate and this is going to accept that H. So this is an example of, wonderful example of intramolecular Cannizzaro reaction. Intramolecular Cannizzaro kits. Now what is going to happen? What product we are going to get? Just see to it. The more reactive, that is aldehyde, will undergo oxidation and this ketone will undergo reduction. So this will be your molecule, this will be your product. Now, after all these things, it's till now, it's fantastic. If it's comfortable, do let me know by showing thumbs up sign along with hearts. Then I'm going to give you best example of this blend of aldol and Cannizzaro reaction. Just see to it. Very, very awesome example. Special example, better to say. Special example. If it is given like this, one molecule of or one equivalent of acetaldehyde, one equivalent plus 4 equivalents of formaldehyde, HCHO. OH negative. Now, my dear students, this type of question, once you have done, what you have done at that time, it's one equivalent and that was having three equivalents, but here it's four equivalents. With three equivalents, what you have done? With three equivalents, you have done like this. See kids, with three equivalents, we have gone with 3 times aldol formation, 1 carbon and 3 CH2OH. We have done like this. Do you remember? Dear students, do you remember? Now, neither this molecule is having alpha hydrogen nor this molecule is having alpha hydrogen. Till now, 3 times aldol formation has taken place. Thrice aldol formation. Thrice aldol formation, it has taken place. Till now. Now, what's new? Without alpha hydrogen, what do you think? Without alpha hydrogen atoms, neither this nor that is having. So, this is more reactive. This will undergo oxidation and this will undergo reduction. So, this will also become RCH2OH. Now, on one carbon, we are having how many CH2OH? We are having 4 CH2OH. Now see kids, this will be our product. Can you remember this sign? Which sign is it? Swastik sign. Do you remember? This is swastik sign and this is polymer, and now it is Cannizzaro reaction. 3 times aldol formation, and once it is being Cannizzaro reaction, kids. Are you able to get it? Do let me know. Can you get it, my dear friends? Do let me know, everyone. Is it clear to all of you? Okay, now. So now I'm going to give you one very special example, which would like, you will say that it would undergo Cannizzaro reaction. No. Some will say it will undergo aldol condensation. Very confusing. Let's see. What you are going to say, just see to it. Kids, this example. Everyone see to it. Well-known example I am going to deal with. See kids. Just see to it, everyone. Now see kids. Are you ready, everyone? Is everyone ready, my dear students? So what I was going to tell you, very interesting example. Or you can say, you can call it exceptional case. Some people will also say exceptional case, but in chemistry there is no exception. But you can call it, just to keep memories, exceptional case. If you are provided with this compound CH3 HCH double bond O, and if you read out your NCERT, so NCERT writes in between the lines. In NCERT, the heading is aldol condensation, but the first line they have given at least one alpha hydrogen is required for aldol formation. So it's misguiding. NCERT has not written anything wrong. The heading is aldol condensation, but what NCERT has written, one alpha hydrogen for aldol formation. So one for formation, one for condensation, at least two acidic alpha hydrogen atoms are required. Now see kids, this compound is having how many alpha hydrogen atoms? One. So what do you think? It would undergo aldol condensation or Cannizzaro reaction? What's your answer? This reactant will show aldol condensation or Cannizzaro reaction. What do you think? Doesn't show. Yeah, this hydrogen is not acidic. Remember that. Not acidic. This hydrogen is not acidic. So it will show Cannizzaro reaction. It will not show aldol condensation. This will go Cannizzaro reaction. Now, why this hydrogen is not acidic? Let me explain. Because if this carbon is going to lose its proton, then this carbon will develop negative charge, and if this carbon has developed negative charge, these methyl groups, they are going to donate electrons, and this carbon's negative charge is highly unstable. So this compound is highly unstable. So this will not get formed. So OH negative cannot take this proton. So it would rather like to act as nucleophile, and if it is acting as nucleophile, this will proceed towards Cannizzaro reaction. So what is the name of this compound? This compound is known as isobutyldehyde. Isobutyldehyde, or you can say 2,2-dimethyl acetaldehyde, whatever you want to say, you can say. Wow, my dear students, Karan Chawla, thank you, Karan Chawla. Kids, hit the like button, at least make it 80. Smash the like button, kids, make it 80. Now see, let me tell you one more thing. If you are provided with some very, very interesting things, I am going to tell you. See kids, let me write down all the things at a single place, just see to it. CH3, CH double bond O, H, CH double bond O. Now CH3, CH double bond O, one arrow, second arrow. This is having one arrow, second arrow. I'm going to write down 4 reactions so that you are not going to miss your marks. Very, very important. See, if I write dilute NaOH, what I will get? If I write down concentrated NaOH, what I will get? Here also, if I write dilute NaOH, what I will get? And concentrated NaOH, what I will get? Now, 2 reactions you know very well. There you are not going to miss anything. First, this you will get proton aldehyde. Very well, you know very well. No mistake you will do. This is proton aldehyde. Very well. Right? You know very well. Proton aldehyde. Now, what do you know else? You know one more thing very well, that concentrated NaOH, Cannizzaro reaction, it will show Cannizzaro reaction, that CH3OH you will get and HCOONA you will get. These 2 things you know very well. But this is concentrated NaOH. As I have told you, you will get CH3, CH double bond CH whole N, CHO polymer brown resonance mass, right? Now, if I say dilute NaOH, this reaction is absolutely missing in NCERT. You will get compound, and see, let me write down with very good color, C6H12 O6. Now your bio students, some of you will say glucose, some will say fructose, some will say mannose, some will say galactose, but it is none of them. This is oh my god, Vedha Janani. Great, Vedha Janani, great. Oh, great. This is formose. Formose. A brown resinous mass. Polymer brown resin. It's a polymer, kids. Now, out of these 4 reactions, 2 are missing in NCERT and 2 are given in NCERT. So it really holds a whole lot of weightage, my dear friends. So everyone just remember about acetaldehyde, just remember about formaldehyde. I have given this memory chart. Yeah, Vedha Janani, that's really fantastic. I will appreciate your memory that you are able to hold this in your hippocampus. That's a fantastic thing. Now, my dear students, all what I have told you in the starting, I have completed. Only one thing is left, that is ozonolysis. How many of you are ready for ozonolysis? But before I proceed towards ozonolysis, let me tell you one more thing. This is chloral. Now, this is chloral, my dear friends. CCl3 CHO. Now, in front of this, if that's provided like OH negative, what do you think? This is the aldehyde without alpha hydrogen atoms. An aldehyde without alpha hydrogen atoms, name as chloral. My dear student, what do you think? Will it show Cannizzaro reaction? The answer is no. Only 10% Cannizzaro product, rest 90% it will show haloform reaction. So majority it will show haloform, but right now I am not going to deal with haloform, kids. Why? I haven't taught you haloform reaction. So whenever I am going to teach haloform reaction, then I will let you know that why this compound is going to show haloform rather than Cannizzaro reaction. This compound will show haloform rather than Cannizzaro reaction. At that time, I will let you know why this compound will show haloform reaction. Now, kids, it's a time for what? The time for ozonolysis. Let's deal with ozonolysis, my dear friends. Ozonolysis. This is very, very important. 2 types of ozonolysis are there. One is oxidative, one is reductive. So ozonolysis is mainly of 2 types, oxidative and reductive. So let me write down. One is reductive ozonolysis, one is being oxidative ozonolysis. Reductive, oxidative. Reductive is done in presence of O3, zinc and water. Oxidative is done O3, water. In reductive ozonolysis, in place of zinc, dimethyl sulfide can also be used. In place of zinc can be used. In place of zinc, you can use dimethyl sulfide also, right, kids? Now, so this ozonolysis, I would like to say 15 star, very, very important. Without this, we cannot start anything. Now, in this ozonolysis of oxidative ozonolysis and reductive ozonolysis, we are going to deal with 2 types of compounds. One is alkene and one is alkyne. One is alkene, another one is alkyne. So we are going to deal with 2 types of compounds ozonolysis. One is alkene and alkynes. So first we will start with alkene. Once we are able to understand ozonolysis of alkene, we can do the ozonolysis of alkynes also. So everyone is ready, kids? So let me write down alkene and let's see what is going to happen with alkene's ozonolysis. Okay, kids? Now see, if we are having compound like this, CR1, R2, double bond CR3, R4. And if I am going to react it with ozone, ozone is reactive. So let's see, we will get ozonide. We will get ozonide CR1, R2, CR3, R4, and this ozonide we will get. You know that this ozonide is highly reactive because of this peroxide linkage, highly reactive. It is highly reactive, my dear students. Now, the thing which is reactive will not be stored in this way. So, whenever you are going to provide zinc and water, what is going to happen, my dear student? This is zinc, and that is water. Now, let's see. This carbon is saying one oxygen I can keep with me. That carbon is saying one oxygen I can keep with me. The only one oxygen is left. What is saying? I will capture that oxygen, but zinc is saying I have got more power to undergo oxidation because I am being very good reducing agent. So this oxygen I am going to keep with me. So it will form, zinc will form Zanu, Zn will convert into Janu, and those compounds will definitely get converted into like this CR1, R2, double bond O, C double bond O, R3, R4. Now see kids, in the examination, we will not be having this much of time to deal with such type of reactions. So how to do it easily in the examination? Short trick. Just see the short trick, Baba HSP short trick, and apply this in short. They will give you O3, they will give you Zn, they will give you water. Nothing you are supposed to do. You have just to break this bond. Ting, 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 ting. Break this bond. Carbon-carbon bond should be broken along with sigma. Pi bond will get broken. Put oxygen, oxygen. And if you want to go back, compress it and remove oxygen. You will get the same compound. Kids, are you able to understand? Is it clear? Now let's see how much you are understood. CH2 double bond CH2 is undergoing reductive ozonolysis. Let's see what product you are going to get. If you are able to understand O3, zinc and water, CH3, CH double bond CH, CH3, CH3, CH3 double bond CH3, CH3. What are you going to get, kids? Do let me know. If everyone is able to understand, do let me know what you are going to get. In the first, you will get 2 molecules of formaldehyde. Am I right? In the second, you will get 2 moles of acetaldehyde. Am I right? In the third, you will get 2 moles of acetone. Am I right? So I hope that you are able to understand. From these 3 examples, we got very good. Vedha, Janini, Gautam, very good kids. We have learned one thing. If the alkene is symmetrical, we will get same type of molecules. So this was symmetrical. This was symmetrical. This was also symmetrical. When the alkene is symmetrical, we'll get same type of molecules. That is the most important thing, my dear students. Now, if the alkene is not symmetrical, what we will get? See kids, the alkene is not symmetrical. Suppose they have given you compound like this, CH3, CH, double bond C, CH3. Or they have given molecule like CH2, double bond CH with more than one molecule, CH, double bond CH, CH3. Then can you understand what type of product you are going to get, kids? Definitely. Just see to it. Here we will get one molecule of acetaldehyde CH3, CH double bond O, another molecule of acetone, CH3, C double bond O. Now the second molecule, you can see the bond will get broken from here and the bond will get broken from here. We will get formaldehyde, that is CH2 double bond O. You will get glyoxyl because CH, this side also it has broken up and that side also it has broken up. And there you will get acetaldehyde like this, CH double bond O, and this is being CH3. You're going to get molecules like this. I hope that everyone is able to understand. I hope that everyone is able to understand. Kids, do let me know. Is everyone able to understand? Okay. Now, my dear students, suppose if the examiner is going to give you a question like this. They have given question like this. Suppose mixture of ozonolysis and aldol condensation. See what they are going to give you. They can give you O3, zinc and water has given A, and A reacted with dilute NaOH and heat is giving out B. Now they are asking what is B. Now dear students, if you don't know ozonolysis, you won't be able to do this question. If you know ozonolysis, you can do this question. Just what we are supposed to do, break it from here and you will get A as CH double bond O, CH2, 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 4 CH2, 1 CH2, second CH2, third CH2, fourth CH2 and CH double bond O. Now aldol condensation, after ozonolysis we are supposed to do aldol condensation. Just remove its hydrogen and the ring of 5 membered will get formed. This will be the ring, my dear friends. Just see to it. Is everyone able to get the same answer? If yes, then you are genius. This is the product. So this is blend of aldol condensation and Cannizzaro, ozonolysis, reductive ozonolysis and cyclopentenyl aldehyde. So we'll say cyclopentene carbaldehyde. Its name is cyclopentene carbaldehyde. Cyclopentene carbaldehyde. I hope that everyone got it, my dear students. Is it clear to each and everyone? You got it? Got it. Now, let me tell you the same reductive ozonolysis of alkynes. Right now, I've told you about alkenes. Now, let's see if we are provided with alkynes. R1, C, triple bond C, R2. And they have given you O3, zinc and water. O3, zinc and water. O3, zinc and water. Now, no need to remove sigma bond because oxygen says I need only 2 bonds. So break pi bond and what will you get? R1, C double bond O, C double bond O and R2. That's it. Are you able to understand? Let me give you example. Suppose acetylene is provided CH triple bond CH, or propine is provided C triple bond CH, or butadiene is provided like this. So in these 3 cases, what you are going to get? See to it, everyone. First case, what will you get? Second case, what will you get? Third case, what will you get? Just see to it yourself. Then I will write down the product. Find it out whether your answer is getting matched with my answer or not. In the first case, I am getting CH double bond O, CH double bond O, that is glyoxyl. In the second case, I am getting CH3, C double bond O, HCH double bond O, methyl glyoxyl. And the third case, I am going to get CH3, C double bond O, C double bond O, CH3. I hope that everyone is able to understand glyoxyl, methyl glyoxyl, dimethyl glyoxyl. Is it clear to all of you? It's the same answer everyone is getting, my dear student. Just to let me know, 76 likes. Kids, what are you doing? Hit the like buttons, make it 80. So much hard work your Baba is doing. At least make it 80, kids. Smash the like button. I want to see increase up to 80. Make it 80, kids. What are you doing? Now, see kids, everyone see to it. I'm going to deal with oxidative ozonolysis. This was reductive ozonolysis. I'm going to deal with oxidative ozonolysis of alkenes and alkynes. Now let's see. R1, R2, C double bond C, R3, R4. If you are not using zinc, then what will happen? O3 and water only. So the bond will get break from there in the same way, in the same fashion. So you will get R1, R2, C double bond O, C double bond O, R3, R4 plus H2O2. Because right now zinc is not there. Once the zinc is not given, so who is going to take that third oxygen? Water is going to take that third oxygen, and water will form H2O2, hydrogen peroxide. So hydrogen peroxide is an example of MOA. What do you mean by MOA? Mild oxidizing agent. This mild oxidizing agent will oxidize aldehyde but cannot react with ketones, because ketones are more stable or more inert. So remember that one thing. This MOA means MOA. Who is MOA? H2O2, being mild oxidizing agent, will oxidize aldehydes but no effect on ketones. But no effect on ketones. No effect on ketones. Ketones will remain same. Now let me give you one example so that you can understand each and everything, my dear students. Let me give you one example so that each and everything should get clear to all of you, my dear students. Just see to it. Number of pages I have used, kids, just to make you understand each and everything. See, kids, everyone see to it. If I give you compound like this, that CH3, CH double bond CH, CH3, and let me try to make it comparative. One oxidative and one reductive. Let me write down O3, zinc and water. This is reductive ozonolysis. O3 and water. This is oxidative ozonolysis. So there I will get simply 2 moles of acetaldehyde. It will get stopped over here. But in this case, the acetaldehyde will convert into acetic acid because hydrogen peroxide will oxidize the molecule. So this will be the product in oxidative ozonolysis. Very good. Fantastic, my dear friend. Now see to it. If I give you this reactant CH3, CH2, CH double bond CH, CH3, and if I write down O3 and water, what will you get? O3 and water gets O3 and water. So the bond will get broken up from here, and this is case of oxidative ozonolysis. So 3 carbon acid CH3, CH2, COOH I will get, and 2 carbon acid COOH and CH3. These will be the molecules. Now my dear student, I hope that this is clear to all of you. This much is clear to all of you. Now see, if I use molecule like this CH3, CH3, C double bond C, CH3, CH3, and if I do this ozonolysis or this ozonolysis, O3, zinc and water if I use, or if I use O3 and water in the same two, the bond will get broken up from here and the product will remain same because ketones are not affected. So I will get 2 moles of acetone. Are you getting my point, my dear students? Is it clear to each and every one of you? I hope this is clear to each and every one of you. Likes are just 77. Only 3 likes we require to make it 80. Kids, hurry up, smash the like button, make it 80. Now, my dear students, let me tell you one very important example or note is in case of formaldehyde, this is note, we are getting compound like this and we are doing the oxidative ozonolysis kits. O3 water. Now how it will proceed? It will give you HC double bond OOH. Now my dear friend, this is the only carboxylic acid in the world which is having CHO group. This is very unique example of carboxylic acid. The only carboxylic acid with CHO group. There is no other carboxylic acid with CHO group. So the reaction will further proceed to give carbon dioxide and water. So in this case, the final product is carbon dioxide and water. Carbon dioxide and water. So for example, if somebody is going to give you compound like this, that CH3, CH double bond CH2, now they are going to give you the product O3 and water. What should be the product? So you have to break it from here. This will convert into acetic acid CH3 COOH, but that will further give you carbon dioxide and water. I hope that everyone is able to understand. Is it clear to all of you? Is it clear to all of you, my dear students? Yeah, very good, Gautam. It will give tolerance test and phalanx test also. That's really fantastic because it is having CHO group. Now let me tell you about alkyls. So if I say R1 C triple bond C R2, and if I am using oxidative ozonolysis O3 and water, first it will break to give you compound like this R1 C double bond O and C double bond O R2. Now this is very interesting example because I have told you that H2O2 cannot attack on ketones, but these are special type of diketones. Special ketones kits, special ketones, that is diketones kits, very important, diketones. So the bond will break and this molecule will further convert into R1COOH plus R2COOH. Let me tell you with the help of one example. Suppose you are provided with compound like this CH3 C triple bond CH2 CH3, and if they have given oxidative ozonolysis O3 and water, what will you get kids? First it will give you diketone CH3 C double bond O C double bond O CH2 CH3, and now this will break from here because it is special type of ketone, and you will get finally this H2O2 will break it to give you CH3 COOH and propanoic acid CH3 CH2 COOH, and water H2O2 will convert into water. I hope that everyone is able to understand. Now my dear student, let me tell you one note, and this is a full and final. The most important thing I am going to tell you kids, what is that? The thing is, like oxidative ozonolysis, this is given in class 11th, like oxidative ozonolysis of alkenes and alkynes, same product we will get, same product will be given by KMnO4 acidic medium plus some heat or K2Cr2O7 acidic medium. Means whatever the product we have obtained from oxidative ozonolysis, if we apply these two type of reagents, we are going to get same type of product kits. We will get same type of products. This is really very important thing, kids. We'll get same type of products. So this is all for today, and thanks for watching, my dear students. It's really awesome that number of answers given by you, they are very fantastic answers. Now, my dear students, if you really liked it, I would like to give you one question at the last, and yes, everyone has to write down homework questions answer, right? So the homework is so you are supposed to find out B. What is B? This is your homework. So kids, right now I have got class at 2 o'clock. That is class of All India mock test. So I have to go, and within time, exactly at the accurate time, I have completed this session. So bye to all of my dear students. God bless you. Love you. Bye kids. Bye.